Finding the area under a curve uses the fundamental theorem of calculus, which links differentiation and integration. If we have a curve, we can use differentiation to find the gradient at any given point. Integration allows us to calculate the area underneath a curve, or area between two curves, if we find the points of intersection with the x-axis or the two curves. To do this, we need a start point and an end point. We then calculate the definite integrals for these limits. So if we wanted to calculate the shaded area in this diagram, we've got a lower limit of 0 and an upper limit of 1. So to determine the area of the shaded section of this curve, we are integrating 2x cubed with respect to x between 0 and 1. So to find the area under a curve, we need to determine the limits. These may be given in the question, integrate, and then find the definite integral or the area for these limits. So we're going to calculate the area shown in the diagram. We've got the curve y equals x squared plus 5, and our limits on the area shaded are -2 as our lower limit and 3 as our upper limit. So our area equals the integral of x squared plus 5 with respect to x from -2 to 3. First of all, we're going to write our square bracket and integrate the first term as x cubed over 3 plus 5x, and our limits go on the outside of our square bracket. We now substitute those values in. First of all, we substitute in our upper value, so we've got 3 cubed over 3 plus 5 multiplied by 3, and we're going to subtract the lower limit substituted, which is -2 cubed over 3 plus 5 multiplied by -2. Now we can evaluate the first bracket. So 27 over 3 plus 15 is 24. And we can evaluate the second bracket, which gives us -38 over 3. And if we make that have a common denominator, we have 72 thirds plus 38 thirds. And that gives us an area of 110 over 3 square units for the curve y equals x squared plus 5 between the limits of -2 and 3. So the next example, we want to calculate the area shown in the diagram. And in this example, we're told that the curve is y equals 2 cos 2x. We've got a shaded in area that's above the x-axis, but we will need to determine what the limit is of our shaded in area. So we know that a cos x curve has a period of 2 pi, and a 2 cos 2x curve has a period of pi. So if we split our curve up into quarters, we know that the limits of the shaded area are 0 and pi over 4. So now we can set up our integration. So the area is the integral of 2 cos 2x with respect to x from 0 to pi over 4. And that becomes 2 in front of our integration symbol so that we can integrate the function independent of its coefficient between 0 and pi over 4. Now, cos 2x is a composite function, so remember when we're integrating a composite function we need to divide by the derivative of the bracket. So our area is going to be 2 multiplied by, and we open our squared brackets, cos goes to sine of 2x because the bracket doesn't change, we're dividing by 2, and our limits are pi over 4 and 0. So the next thing we need to do is simplify that. So area is going to equal sine of 2x between the limits of pi over 4 as our upper limit and 0 as our lower limit. So we need to substitute these values in to find our definite integral and therefore our area. for our y equals 2 cos 2x curve. So we've got sine of 2 multiplied by pi over 4 minus sine of 2 times 0. Now we need to simplify this, and that becomes sine of pi over 2 minus sine of 0. Now we can get the exact values of these terms by looking at our sine curve, and we know that sine of 0 is 0, because when x equals 0, our y value is 0, and at pi over 2, our y value would be 1, so we can substitute in 1 take away 0, and so the area shown in this diagram is 1 square unit.